Permutations count the number of ordered arrangements of a set of objects. For example, suppose we have 5 students competing to see who can eat the most Detroit deep dish pizzas. In this competition, there is a first, second, and third place. How many ways can first, second, and third place be filled with the 5 competitors? Well, Joe in first, Joseph in second, and Joey in third is different from Joey in first, Joe in second, and Joseph in third. Here, order matters, since rearranging the same names gets a different outcome. How many different first, second, and third place arrangements are possible? For first place, we have 5 choices. After choosing first place, we have 4 choices left for second place. After choosing first and second place, we have 3 choices left for third place. The total number of arrangements is 5 times 4 times 3, which is equal to 60. So anytime we are counting the arrangements of objects where order matters, like in this competition, we are working with permutations. In general, if we have n objects and we want to arrange r of them, we write this as npr, or one of these other notations. The formula for npr is equal to n factorial divided by the quantity n minus r factorial. N is the total number of objects we are choosing from, and r is the number of positions that we want to fill. Here, our n objects are distinct. There's no repeated selection for the positions that we're filling, and 0 is less than or equal to r is less than or equal to n. From the example before, n would equal 5 and r would equal 3, so we have 5p3. Using the formula, we get 5 factorial divided by 5 minus 3 factorial, which is equal to 5 factorial divided by 2 factorial. Since 5 factorial is 5 times 4 times 3 times 2 times 1, and 2 factorial is 2 times 1, the 2 times 1 will cancel out, leaving us with 5 times 4 times 3 in the numerator, which equals 60. Let's look at one more example. Suppose we have 8 students. We want to choose a president and a vice president for a club. If we wanted to count the number of ways that we could have a president and a vice president from our 8 different students, we would be working with permutations again. That is because if Alex was president and Jordan is vice president, that's different than if Jordan is president and Alex is vice president. For president, we have 8 choices. After choosing the president, we have 7 choices left for vice president. So the number of arrangements is 8 times 7, which is equal to 56. We could also write this as 8p2, because we are choosing from 8 students and filling 2 positions. Using the formula, we get 8 factorial divided by 8 minus 2 factorial, which is equal to 8 factorial divided by 6 factorial. Here is 8 factorial written out and 6 factorial written out, and what do you notice? 6 times 5 times 4 times 3 times 2 times 1 cancels out. We are left with 8 times 7, which equals 56. So, permutations are used when order matters. They let us count the number of arrangements of all or a subset of objects. N factorial is also the same as npn. That is because if we are choosing n objects and arranging all n of them, we are just counting all possible arrangements of the full set of n objects. So npn equals n factorial divided by n minus n factorial, which is equal to n factorial divided by 0 factorial, which is equal to n factorial, since 0 factorial is equal to 1 by definition. If you found this video helpful, consider subscribing, commenting, or liking the video to support the channel. I'm Joe, and thanks for spending some time with me.